Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Today we'll solve HP board model question paper chemistry term 2 of class 11. So let's begin with the questions. The first question is, when system does not exchange heat with surroundings, the process is called adiabatic process. Which of the following is not a Lewis acid? So pH3 is not a Lewis acid because it contains lone pair of electrons. Which of the following can act as oxidizing as well as reducing agent? Answer is hydrogen peroxide. With oxygen having -1 oxidation state, can undergo oxidation as well as reduction. How many hydrogen bonded water molecules are associated with copper sulfate pentahydrate? So answer is 1. One water molecule forms hydrogen bond, 4 form coordinate bonds. When sodium reacts with excess of oxygen, the oxidation number of oxygen changes from 0 to -1 because it forms sodium peroxide. Group 13 element shows +1 and +3 oxidation state. Inductive effect involves displacement of sigma electrons resulting in polarization. The IUPAC name of a given structure is 3-methyl pentane. Wood's fitting reaction is used to unite one alkyl and one aryl halide. The ease of dehydrohalogenation of different halogens is in the order: iodides are more reactive than bromides, are more reactive than chlorides. All carbon atoms in benzene are sp2 hybridized. If delta G is negative, then the process is spontaneous process. In the relation Kp is equal to Kc into RT raised to power delta N. Delta N is equal to number of moles of product minus number of moles of reactants. Loss of electrons by any species is called as oxidation. Lithium is the only alkali metal which, when burnt in air, forms a mixture of oxides and nitrides. Thermodynamically, the most stable form of carbon is graphite. The general electronic configuration of group 13 elements is Ns2np1. If a covalent bond breaks in such a fashion that the shared pair of electrons remain with the fragments, the cleavage is called heterolytic cleavage. Two successive members of a homologous series differ from each other by CH2 unit. The process of elimination of carbon dioxide from carboxylic acid is known as decarboxylation. Calculate the heat of combustion of ethylene gas to form carbon dioxide gas and water gas at 298 Kelvin and 1 atmospheric pressure. The heat of formation of carbon dioxide gas, water and ethylene are -393.7, -241.8 and +52.3 kilojoules per mole respectively. The reaction, because it's a combustion reaction, so to find out the heat of combustion, we must remember the definition of enthalpy of combustion. It is the heat produced when 1 mole of a substance is completely oxidized in excess of air. So ethylene plus oxygen to form carbon dioxide and water, this should be 1 mole. So to find out the enthalpy of this reaction, we use the formula. The enthalpy of any reaction is equal to sum of enthalpy of formation of products minus sum of enthalpy of formation of reactants. The values of enthalpy of formation of products and reactants are given, and for oxygen it will be 0 because oxygen is present in its standard state, so it's 0. So products are carbon dioxide. The enthalpy of formation for carbon dioxide is 393.7. As there are 2 moles of carbon dioxide, we multiply it with 2. Similarly, for water also, we multiply the enthalpy of formation -241.8 into 2 because there are 2 water molecules here. Then we add these up. We get this answer, -1271. And from it we subtract ethylene, and oxygen is 0, so 3 into 0 will be 0. So we subtract this and the answer comes out to be minus 1323.3 kilojoules per mole. Next question is differentiate between classical and photochemical smog. So classical smog is formed due to buildup of sulfur oxides and particulate matter from fuel combustion. Photochemical smog is formed due to photochemical reactions of sunlight on nitrogen oxides and hydrocarbons produced by automobiles and factories. Classical smog involves smoke and fog. It does not involve any smoke or fog. It occurs in cool, humid climates in winter. It occurs in warm, dry, and sunny climates in summer. It has high concentration of sulfur dioxide and is reducing in character. It has high concentration of oxidizing agents and is oxidizing in character. Question 23. Explain the term electrophile and nucleophile with examples. So, electrophile are positively charged or neutral species which are deficient of electrons and can accept a pair of electrons. These are called electrophiles, means electron loving. So, positively charged electrophiles are H plus, Cl plus, etc. Neutral electrophiles are electron deficient molecules like AlCl3, BF3, SO3, etc. Nucleophile are reagents which contain an atom having an unshared or lone pair of electrons. These can be negatively charged or neutral and are electron rich. For example, negatively charged examples are hydrides, halides, chlorides, and neutral are molecules like ammonia having lone pair of electrons or amines or water. Explain the relative stability of conformation of normal butanes. So, anti-conformation has CH3 on opposite sides to each other. This is most stable. In skew, the conformation is in staggered form, but methyl are not very far apart from each other. In eclipsed, the methyl, they are eclipsing each other, but methyl groups are still far away from each other. But in fully eclipsed, methyls are overlapping each other. They are closest possible. So the relative stability is anti is more stable than skew, than eclipsed, than fully eclipsed. Next question is explain Leela, Chatler's principle. So it states that if a system in equilibrium is subjected to a change of concentration, temperature, or pressure, the equilibrium will shift in the direction that tends to undo the effect of change imposed. For example, if concentration is increased, reaction will go in the direction in which the concentration decreases. State the law of chemical equilibrium. To arrive at the law of chemical equilibrium, let us consider the general reversible reaction where A moles of A combine with B moles of B to form X moles of X and Y moles of Y. Now reaction can proceed in forward as well as in backward direction. So rate of forward direction as per law of mass action will depend upon the concentration of reactants, or it will be equal to a constant rate constant of forward direction into concentration of A raised to power A moles into concentration of B raised to power B. Similarly, rate of backward direction will be Kb into X raised to power X into Y raised to power Y. Now, at equilibrium, rate of forward is equal to rate of backward direction upon Kb is equal to products upon reactants. This is constant. So, this mathematical equation is called law of chemical equilibrium. In words, it can be expressed as the product of molar concentration of products raised to power their stoichiometric coefficients to the product of molar concentration of reactants raised to power their stoichiometric coefficients is a constant known as equilibrium constant. Define specific heat. Specific heat capacity of a substance is defined as the amount of heat required to raise the temperature of 1 gram of substance through 1 degree centigrade. State the first law of thermodynamics. It states that energy can neither be created nor destroyed, although it may be converted from one form to another. Explain why tertiary carbocation is more stable than secondary and primary carbocation. We know that an alkyl group is electron releasing in nature. The alkyl group attached to a positively charged carbocation will tend to disperse the positive charge. So in a tertiary carbocation, there are 3 electron releasing groups which are dispersing the positive charge. So this will be most stable. More dispersal means more stability. In comparison to secondary, which has only 2 electron releasing group, in comparison to primary, which has only 1 electron releasing group. State and explain the electromagnetic effect with examples. So electromagnetic effect is a temporary effect which comes into being when an attacking reagent attacks, and in this effect the electrons of the multiple bond will go to one of the atoms. As a result, there is polarization. The place where electron go becomes negatively charged, and from where the electrons go becomes positively charged. So the transfer of shared pair of electrons of the multiple bond to one of the linked atoms results in electromagnetic effect. The phenomena of movement of electrons from one atom to another in multiple bond on the demand of attacking reagent is called electromagnetic effect. This is a minus E effect because the attacking reagent will attach to that carbon atom which is opposite to the one to which the electrons have moved. There is another electromagnetic effect where the electrons, the attacking reagent moves to that carbon atom where the electrons go. That is plus E effect. What is peroxide effect? When an HBr is added to unsymmetrical double bond in presence of organic peroxides, for example benzoyl peroxide, the reaction takes place opposite to the Markovnikov's rule. This is known as peroxide effect. So in propane, this is an unsymmetrical double bond. One has 1 hydrogen and the other has 2 hydrogens. When HBr is added, the negative part of HBr will move to the carbon atom which is having more number of hydrogen atoms. This is contrary to the Markovnikov's rule and is called anti-Markovnikov's rule, and this effect takes place in presence of peroxide, so it is known as peroxide effect. State Huckel's rule of aromaticity. For aromaticity, the pi electron cloud of an aromatic compound must contain a total of 4n plus 2 pi electrons, where n is an integer equal to 0, 1, 2, 3, etc. This is known as Huckel's rule. For example, benzene is an aromatic compound because it has 6 pi electrons, which obeys the 4n plus 2 pi electron rule formula. Here the value of n is 1. So 4 into 1 plus 2 is 6. So as benzene has 6 pi electrons, it's aromatic in nature. Write short note on the following. Wood's reaction. When an alkyl halide, usually bromide or iodide, is treated with sodium in dry ether, a symmetrical alkane containing twice the number of carbon atoms of alkyl halide is obtained. For example, methyl bromide, 2 molecules will react with sodium to form NaBr, and these two attach with each other. So the alkane that is formed contains 2 carbon atoms, whereas alkyl halide had only 1. This is Wood's reaction. In Friedel-Crafts reaction, when we treat benzene with alkyl halide in presence of anhydrous aluminum chloride, the alkyl group gets attached and alkyl benzene is formed. This is known as Friedel-Crafts alkylation reaction. If acyl halide is added in presence of anhydrous aluminum chloride, acyl group can get attached. That is also Friedel-Crafts reaction, but it is called Friedel-Crafts acylation reaction. Calculate the pOH value of solution whose pH is 7. So we know that pH plus pOH is equal to pKw, which is equal to 14. So putting the value of pH as 7, we get pOH is equal to 14 minus 7 is equal to 7. At equilibrium, the concentration of N2 is 3 into 10 to the power minus 3 moles, oxygen 4.2 into 10 to the power minus 3 moles, and nitrogen 2.8 into 10 to the power minus 3 molar in a sealed vessel at 800 Kelvin. So Kc for the reaction, when the reaction is N2 plus O2 gives 2NO, will be concentration of products raised to power stoichiometric coefficient 2 upon concentration of reactants. Now, putting the value of concentration in this expression, NO was 2.8 into 10 to the power minus 3 square upon N2 was 3 into 10 to the power minus 3, and O2 4.2 into 10 to the power minus 3. On solving, we get 0.622. Also, the units cancel each other out, so it's a unit less value. The equilibrium constant Kc is equal to 0.62. What is the cause of hardness of water? So hardness of water is caused due to presence of bicarbonates, chlorides and sulfates of calcium and magnesium in water. The bicarbonates, calcium bicarbonate and magnesium carbonate cause temporary hardness, whereas the chlorides and sulfates, CaCl2, CaSO4, MgCl2, MgSO4 cause permanent hardness. Why ice floats in water? In ice, water molecules are joined in an extensive three-dimensional network in which each oxygen atom is tetrahedrally surrounded with 4 hydrogen atoms, 2 by covalent bonds and 2 by hydrogen bonds. So as a result, the resulting structure is an open structure with a number of vacant spaces, because of which its density is less. In comparison, in water molecule, the hydrogen bonds get broken and the molecules come closer, so density increases. So ice is less dense than water, so it floats on water. Define oxidation and reduction in terms of electron transfer. So oxidation is a process in which one or more electrons are lost, and reduction is a process in which one or more electrons are gained. For example, sodium and chlorine form sodium chloride is an oxidation reduction process where transfer of electron takes place from sodium to chlorine. Sodium loses electron, undergoes oxidation, chlorine gains electron and undergoes reduction. Can we store copper sulfate in iron vessel? As iron has a greater tendency than copper to give electrons, it undergoes reaction with copper sulfate, so we cannot store copper sulfate in iron. And the reaction that takes place is iron plus copper sulfate forms copper plus iron sulfate. So the iron vessel, when the iron reacts with copper sulfate, will develop holes in it, so we cannot store copper sulfate in iron vessel. Define electrode potential. It is the potential difference set up between the metal and its solution. So metal and its solution, it either develops a tendency to give electrons or accept electrons. So it's a measure of tendency of an electrode in a half cell to gain or lose electrons. What do you mean by electrochemical series? The arrangement of elements in order of decreasing reduction potential values is called electrochemical series. Define disproportionation reactions. These are the reactions in which the element in one oxidation state undergoes simultaneous oxidation as well as reduction. For example, when hydrogen peroxide undergoes decomposition, it forms water and oxygen. The oxidation state of minus oxygen as -1 changes to 0. Here it undergoes oxidation, but at the same time it changes to -2 in water. Here it undergoes or reduction. So it's simultaneously undergoing oxidation as well as reduction. This type of reaction is called disproportionation reaction. Write the functions of salt bridge. Salt bridge connects the solutions in the two half cells and completes the cell circuit. The second function is salt bridge keeps the solutions in the two half cells electrically neutral. Why beryllium and magnesium do not impart color to the flame? They do not impart color to the flame because the ionization enthalpy values are very high because of their smaller size. So the energy of flame is not sufficient to excite the electrons to higher energy level, and they do not give color to the flame. Why do alkali metals give blue solution when treated with liquid ammonia? It's because alkali metals on reacting with ammonia form ammoniated cations as well as ammoniated electrons. The blue color of the solution is due to ammoniated electron. When ordinary light falls on these ammoniated electrons, they get excited to higher energy level by absorbing energy corresponding to red region. So the visible light is the transmitted light, which is blue in color, so solution appears blue. Why is the oxidation state of sodium and potassium always +1? Because alkali metals have only one valence electron in their valence shell, so they can lose this single valence electron and show +1 oxidation state. Why is sodium metal kept in paraffin oil or kerosene oil or paraffin wax? It's because it's very reactive and catches fire when kept in open air or in water. So to protect the metal and to prevent accidental fires, it is stored in kerosene oil or paraffin wax. Why lithium is the strongest reducing agent? Lithium has high ionization enthalpy, so it should be weakest reducing agent. But because of its small size, it gets hydrated to such an extent that the energy released by hydration compensates the higher ionization energy needed to remove electron. So it becomes the strongest reducing agent, giving greatest energy in solutions. Why alkaline earth metals are harder than alkali metals? Because of presence of two